Welcome back, and I've got a really unusual experiment for you today. What we're going to look at is whether we can make lenses out of a material that is totally opaque. So if you want to refract light or change its direction, one of the ways of doing it is with lenses. And it's pretty obvious the lens has to be transparent to light electromagnetic waves. But you might have seen a video I've done with microwave radiation, shining microwave radiation through wax and seeing it change direction. So what we're going to do today is we're going to build a lens for microwaves that is totally opaque to light. So as I've probably said before, there must be schools all over the country that have objects like this in the back of cupboards somewhere in their physics department, and they have no idea what they were used for. So I'm really glad to get the chance today to show you particularly what these wax lenses are used for. So let me explain the setup I've got here, and that's why I've got such a wide shot at the moment. I'll just put the wax prism out of the way safely. So I've got a microwave transmitter here and a microwave receiver here. And what I'm going to do is I'm going to send microwaves along the top of the table. And it's quite a large distance for this apparatus. So because the beam is diverging, spreading out, it's getting weaker and weaker. So we can detect the microwave radiation. I'm embedding on that a sound signal. So you'll hear the sound being carried by the microwaves. So it's a little bit like a very simple mobile phone transmitter that we're using microwaves to carry a sound signal. And what we're going to do is we're going to use a totally opaque wax lens to bring those microwave radiation that comes out of the transmitter to bring it into a more narrow beam and see if we can get more of the radiation into the receiver at this end of the table. So I've turned on the microwave equipment, the transmitter there, the receiver there, and you might just hear a very faint beeping sound from the receiver. If you can, just to prove that we're transmitting microwaves across the desk. So I hope you can hear it's a very weak signal reaching the receiver. So let's see if we can take this diverging beam, bend it in a little bit and get more of the microwave radiation travelling to the receiver. So the unusual thing about bending microwave radiation is we can use totally opaque wax lenses. And as you can see, this is a biconvex lens, or it's two planar convex ones sort of stuck together. And what we're going to do is put this in front of the beam, and what we're hoping is we'll hear the sound at this end becoming louder, which means that it's receiving more microwave radiation than it was without the convex lens. So you have to listen fairly carefully to this, and I have to get the lens in the right place, but let's see what happens. There we go. I think that's the right place. Took me a while to find it. And to prove that the lens is making a difference, listen to the receiver now and listen to it when I remove the lens. So the lens certainly makes quite a difference. So I do hope you enjoyed that really unusual experiment using wax, a totally opaque material, to make lenses from microwave radiation. Anyway, I'll be making another video soon, and I look forward to seeing you then.